Okay. Today we are talking about iteration 3, and we're just kind of going to run through the spec. It shouldn't take super long. We'll do a really quick kind of clone and look at the Flask stuff really briefly. But thankfully, because you've done that in 4.2 and 4.3 with Jake, you should already get a lot of the concepts of what much of this is about. Most of what we're going to go through today is just describing what we expect from you with iteration 2, what we expect from you with iteration 2, what the kind of key parts of it are, because, there are lots of different parts, and just getting your head around it. So you leave today and you're like, all right, I get what I have to do for the next 3 weeks. Sweet, thank you. Now, in terms of the spec, which is where everything here is, the main things to kind of notice here are that compared to last time, you have iteration 1 and iteration 2. Iteration 1 is now over, so we've blanked that part out, and we now just have iteration 2. So you can actually see here, iteration 1, it's now complete, and most of the stuff's in iteration 2. What do you need to read the spec for? Because you probably read the spec once and you're like, I don't want to read the whole spec again. Well, you just need to read section 2 and section 6 basically, because section 2 describes what iteration 2 is about, and section 6 kind of highlights the work you have to do in a bit more detail, like the interface from the last iteration. Now, for iteration 2, before I even get into it, what content do you need to know for this iteration? Well, iteration 2 relies on all of the week 1 to 3 content. It relies on the 4.2, 4.3 HTTP Flask testing content that we've been through, and it relies on a few things from week 5. So what that means is that besides a few things from week 5, you know everything you need to know for this iteration. It's a big iteration. The things you need to know in week 5 are that we're going to do a lecture on persistence, which is how you make sure that your kind of server keeps the data even once the server ends and restarts. We're going to do a lecture on software design principles, which is going to be 5.1 and 5.3, which again is something where you can just kind of improve and refactor your code a bit. And I'm going to do a lecture that Jake will probably take, because we just gave him the web stuff, on some authentication stuff, which again you could ignore for now. Now the reason I really explicitly point this out is because I know as a student, sometimes you look at these things and you think, oh my god, I can't start because I haven't learned everything. And you know what? You actually can start again. You can do 95% of this iteration, and then there's just a couple little things you can tack on later. So there's nothing stopping you. You're gonna find pretty much no efficiency benefit in waiting until the end of week 5 to start. And we've designed it like that. This project has literally been designed so that everything from today, from when you're watching this lecture onward, assuming you've watched them in order, you are good to go. You are good to start smashing it out with your group. Get to it this week. Get to it on the weekend. Everything's good. So some questions in the chat. Quick question, Ari, some Flask behavior. How does Flask communicate exceptions at the endpoint? We'll talk about that briefly. Diaurora says, will we have access to the iteration 1 tests, not just the results, so we can fix stuff? I've touched on this on the forum a couple of times. We can't give you the iteration 1 test because Python, being an interpreted language, means we can't actually give you the ability for you to run the tests yourself without actually giving you the tests. And if we give you the tests, we can't ever reuse this assignment ever. And these are massive projects that take hundreds of hours of work in terms of writing them and testing them and debugging them and auto marking them and everything like this, right? So it's just like a reality that we can't do that, and I'm sorry about that fact. I'm sorry in the sense that if the uni doubled the budget that they give schools to spend on teaching, I'm sure we could get around that, but I'm operating within the realities available to me, so we can't do that. But we've tried really hard to be helpful in terms of the dry runs, which you can access, in terms of doing the leaderboard, which we gave you a few runs at, and also in terms of what's it called? In terms of actually giving you information about your test back, and I'll actually show you this here. So if you go to your repo, I'm going to post about this tomorrow. If you go to your group repo, I've got a random group here, F17A Eagle. Hi, F17A Eagle, if you're watching this. I've actually pushed a branch to your repo called iter1result. So this has been automatically pushed to your repo. And if you watch this, if you go to this, you'll actually see two text files. And this first text file, well, second text file here, group test group code, is the, I think everyone got 100, so I might open this. I know it's another group, but I think everyone did. I think everyone got 100 for the your tests against your code stuff. So I hope I'm right about that, because I don't want to be like show other students like other people's code, right? But it's like this shows you all of the tests that you ran, right? This is actually a list of all of your PyTests, and it's like here, course test group code. If you look at this one, you'll actually see that, and again, I can't open this one. It actually shows you what the output of us running our PyTests against your code is, right? And that's good because you can use that to debug. Now you might be thinking, oh, that's annoying. I want to see the actual tests. And like, again, I get that. But the best we can do is the dry runs, the leaderboards, and give you the PyTest output. Because the thing is, you in this output, again, I don't want to show you here because it's not, I don't want to put a group under pressure, is like, it actually shows you the names of the tests that we wrote. So like, while we won't give you the actual tests, it will say something like, oh, test channel invite after login. And you can actually go away and test that yourself to figure out what you did wrong, or you can see what you did wrong. Now, in terms of like, what if you got a really bad mark in iteration 1? And you're like, oh, we found out it was just one problem. And we've seen a few groups like this, like all their tests failed because of one problem. We will rerun it for you with some kind of variable penalty. Talk to your tutor about that. Generally speaking, though, if you got like more than 80% of the auto marks for iteration 1, we're probably not going to rerun it except under exceptional circumstances. So that's kind of your mark, really. Now, that's just in terms of your iteration 1 marks. In terms of iteration 2, let's quickly talk about what it's actually about. You can read this properly, right? But the gist of it is that in this iteration, you are going to be implementing, how would you put it? You're going to be implementing your Flask server based on the interface. You're going to be writing tests for your server, not in that order, tests before implementation. And that's what section 2 describes. It's like you're going to implement and test an HTTP Flask server according to the interface. Same as iteration 1. It's just you're doing it with Flask now instead of not Flask, right? We want you to manage sessions and tokens and authentication and persistence of data. These are those two things I mentioned that you can tack on later and worry about next week. So you don't need to worry about that part yet. It's as you understand it here, it's just doing what you did in iteration 1, except for a Flask server. Now, two things that have been added to iteration 2 that are relatively important in terms of structure are that we expect your code to be pilinted, and we expect your code to have good coverage. Okay, so in iteration 1, we were like, you need to have your code be well tested. Now it's like it needs to be well linted, and it needs to have good coverage. So we're broadening the definition of what we understand good code and good tests to be. Okay, that's really important. We've also updated your repo to have a coverage file, right? Which is like where you get your test coverage information from. To have a pylint file, which is where we get your pylint information from, right? This is like the configuration. And we've updated your GitLab CI file, your continuous integration file, that now has, not just the PyTest running, but the coverage checking and the pylint running. So we actually have all of these things now baked in from iteration 2 onwards. So when you run your pipeline, you will find that it's now not just the PyTest, but it's this pipeline actually includes pylint. And when you get a coverage result, we'll actually print the coverage result there for you, right? So this will actually come up here. It's very easy. So if you get 80% coverage, then you're all good. Now, in terms of that coverage number, I wanted to point out with coverage here, your PyTest and pylint should be 100% at all times, right? Because it's easy to do. You write a test, you should pass the test. Your coverage one is not going to be easy to get 100%, and more importantly, you don't have to get 100% all the time, right? So you shouldn't aim for that, and I don't even think the pipeline expects that at all. So like, the pipeline will still pass even if you had 50% coverage. It's just going to be okay. So what that means is that you don't need to stress about getting coverage perfect. That's a kind of thing that you can iterate on as you go. So you always want to have high coverage, but like to move it from 80 to 90 to blah, 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 that's something that you can just go through as you go. Don't stress about coverage as you go. It's going to slow you down. It's going to burden you as you try and get your head around it. Okay, so they're these two new things I mentioned. I'm on the wrong page. Oh, by the way, iteration 2 has been pushed to your repo. So you can see here for F17A Eagle, they've actually, like, we've made a merge request, but they've actually got an open merge request here. And if you click on that, you can actually merge that in. I don't know why it doesn't merge itself in automatically sometimes. We haven't figured that out. We think it's a bug with like GitLab systems, but there you go. Just merge that in if you don't have it, because that's where all the spec and stuff is. So as we've said, iteration 2, it's the same as iteration 1 with a Flask server. Couple of things that we'll talk about next week. PyLint coverage, which we've already talked about. And then the fourth part of it is Git and project management. So that's good commits, merge requests, task board, meeting minutes, meetings, stand-ups, all these things. But the thing is, that's exactly the same as iteration 1. So there's nothing new there. It's just like, that's what you're doing. Same as iteration 1. We'll talk about running the server in a bit because we'll run the server quickly. 4.3 is the same as the last iteration. It's just a really detailed explanation of how to actually implement and test features in terms of, you test a bit, you implement a bit, etc. This is all the same. 4.4 we'll talk about when we do a little quick demo. 4.5 we can talk about too. 4.6 is around the week 5 persistent stuff. You can kind of, again, gloss over that. There's so much you can do without reading, honestly, a lot of this spec. So like, don't feel like getting everything understood is like a blocker for you. 4.7 is a detail, which I'll chat about. We do have a dry run for iteration 2 as well. That means that you can actually see these tests. There are basic tests that make sure your code doesn't completely fail, which means that no group should get 0 for our tests on your code, because we actually give you a few of them. It's a sanity check. It's new this term. You're the first group to get it. You're the first cohort to get it. It's been well received, and we still have it for iteration 2 as well. In terms of the marking criteria, it is similar to iteration 1 in the sense that you have an auto marking section, which is 50%. You have a code quality section, which is 30%. And you have a Git and project management section, which has all been lumped together. And we got rid of assumptions because assumptions is just like this little thing we like to do in iteration 1. In terms of Git and project management here, with this 20%, it's less than the last iteration in terms of like Git and project management used to be more separate. It's because they're pretty easy marks. Like this 20% is yours to lose. It's so easy. It's so easy to get these marks. It's absolutely manageable. And therefore it's just a small component of it. You just do your commits, you get your merge requests, you do your meetings. Like, you don't even have to get your code working to get all of these marks. You don't even have to progress anything to get all of these marks. You just have to follow procedures and follow best practices. Code quality is the manual marking of your code, and auto marking is auto marking. Now, what is auto marking? Now, I know there's a few of you in the chat here that are like, the formula made me cry, Blake, very funny. And, Caleb's like, it's kind of complex. And Blake's making more jokes about the sum to infinities. Very funny. And I just want to take you through it. So it is complex. And you know what? I don't like complex. It's a fairly big tenet of what I work with, is keeping things simple. I think simple things are amazing. They're good for everything. Simple code is less buggy. Simple tests are less buggy. Simple specs are less confusing. Complexity, there's such a high bar for what requires complexity in life. So what I want to do is just spend 3 minutes here taking you through and explaining what in God's name this auto mark thing is and why it exists, right? Because I think there's a good reason for this complexity. I've already explained this to you, but none of you are here, so let's do it again. All right. So here we go. Your iteration 1 mark, right? was... Yeah, you're right. No. Oh, that should be minimum. You're right. Thank you, Halogen. You are correct. That should say minimum. We'll fix that up. So, iteration 1 mark was your test times your implementation, right? And in a way, you could say that like you could rewrite this differently if you wanted to, and you could say that, well, it was like, your tests out of 100 times your implementation out of 100, which gave you a number between 1 and 0, which is like you times that by 100. Basically, it was like the product of the two. Now, if you assume that, your tests were a percentage and your implementation was a percentage, then that just kind of be t times I. Now, this formula was somewhat irrelevant for iteration 1 because you all got 100 in the leaderboard because you're all diligent, amazing students, right? Good job. I think I've never seen something like this. You all got 100%. So, congrats. Every group here. If I click the next page, it's just like, every group got 100% with their own tests on their own code. Great job. And in fact, you all did really well on the implementation stuff. Like a lot of you got really high marks. About half of you got above a 95. Now this is bad for us from a marking perspective, but that's exceptional. And you know what? We added the dry runs this time. We added the leaderboard because we wanted to give you confidence and less stress, and maybe the marks are a little higher than we would have liked, but like I'm just thrilled that you've kind of found it easier, that you've had a good time, that you've been able to see your progress. These are all really good things. So super happy, absolutely awesome. And where this kind of leaves us in terms of iteration 2 is like the iteration 1 marking was pretty simple. The reason we had this T here, even though we kind of knew you'd all get 100 for it, was to demonstrate a point so that when we did the iteration 2 marking, you would get it. Now let me just explain what the iteration 2 marking is. The iteration 2 marking is your tests against your code times by your tests against... it's your tests against your code times by our tests against your code times by your coverage plus your pilot. Conceptually, this is what it is. There's a few things about how this is weighted, but that's kind of what it is. Now, why is your pilot separate? Because it's going to be a tiny amount, right? We want you to pilot your code. We'll give you a mark for it. It's automatable, so we automate it. What's the first one here? Well, here's the fundamental philosophy that informs this mark for iteration 2. It's the idea that your tests don't mean anything if they aren't good coverage. And what I mean by that is you all got 100% in iteration 1, and that's because you could have written one test for iteration 1 and it would have passed and you would have gotten 100% for T. You could have written 10. In fact, some of you have gotten 100 and your tests are quite literally like 3 or 4 times better than other groups, right? And that's not great. We need a mechanism whereby we can say, you wrote better tests, and there's a few different ways we can solve this problem. We've been through a lot of it, but essentially the key thing here is that if we multiply your tests against your code by your coverage, we actually get a true indicator of, you could just do coverage theoretically. But like we want your test to pass, you get a true indicator of like how good your tests are. And the reason that the formula isn't something like, T times C, your tests against your code, times by your coverage, plus your implementation mark when we auto mark you. The reason it's not them separated is because a big philosophical tenet of what we really want to convey is, again, that it's not just your tests and it's not just your implementation. We want you to write working code that is verifiable. The problem with having these two things separate is, again, you could actually barely do any implementation here. You could write one route. You could get basically nothing working or do 25% of it. And then when you go and write your test and your coverage, because you could test and cover all of that, you could get the same marks as another group. So you could actually, under structures like this, you could write 1/5 of the tests of another group and be told that your tests and coverage are as good as them. And that's just not kind of how we think it makes sense. So the idea here is that by tying all of these together, we have a very accurate kind of assessment of how, how good your code is and how well you have covered it in terms of your test. That's the gist of it. I really love it. Maybe that's a bad idea. We'll find out at the end of the term, but I'm confident enough with it. We might have to tweak a few things, but I think it's the right philosophical approach. Maybe we've got the execution not down. We can always reassess it for iteration 3 slightly, but here's the thing. We are saying that 95% of your marks for iteration 2 come from that testing, auto marking, whatever, and 5% of your marks come from Pylint. So that's kind of part of the formula, right? 5% from Pylint, 95% for like us testing your code multiplied by your tests against your code multiplied by coverage. Now, that probably, I'm hoping that makes sense at this point. And then Blake's asking the question, what's with the min and the power to 3? Because that's kind of what actually makes the formula look a bit funny, right? Like if I just showed you 95 times that plus 5 times that, you're going to be like, okay, sure, Hayden, that sounds fine. What's with all this min and stuff? So let me explain this one too. The min is there because we think 99% coverage is good enough. If you get 99% coverage, we think you've done a great job. Perfect job. We don't want to ask for more. You can get 100% coverage, but coverage gets harder. It's really easy to get 80% coverage, and then it's even harder to get 90%. It's even harder to get 95%. Like it's nearly exponentially more difficult. I don't know what the actual mathematical relationship is, but it's a lot more difficult as you get higher. So we don't want to stress you out and say you need 100 to get like perfect here. We're just saying you need to get 99. So the reason we have this thing here that says like, min of, the reason we have a thing here that says, you know what, we're just not going to look at your coverage out of 100. We're actually going to say, oh, it's the min of your C and 100, or C plus 1 and 100. What this is saying here is that if you get 99, that's enough. In fact, I don't even know if that 100 is necessary. Oh, it is necessary in case you get 100 in coverage, right? I was as smooth, Waleed, I was as smooth about this the first time. I know, I'm just having fun. So, minimum of C plus 1 and 100. That's just in case someone gets 100. This could just be C plus 1. We're saying that 99, we'll give you a percent for your coverage. Here's a free percent. Now the real question is the part that gets weird is what is the power of 3 for? You're probably like, all right, Hayden, were you just writing formulas and you were like, yeah, let's put a power here. That'll make it look complicated. Not really. Let me explain this too. So here's what you would normally do. When it comes to coverage, you getting 99% coverage is what we would consider perfect. You getting 60% coverage is what we would consider that you have done nothing. You've done a terrible job. Like your iteration 1 coverage is probably 60% right now if you ran it. It probably is just 60% immediately. Like that's like terrible. If you get 80%, it tells us that like I'm making these numbers up, right? You probably did like okay. You maybe did half the effort. Okay. And if you get like 90%, that means we think you did like, you tried, right? Like you did goodish. Like they don't get caught up on these numbers, by the way, because I haven't sat down and really looked at where these gradients are. I'm just kind of painting a point. And 95% is like, you probably did like 85% of the work. Like, yeah, pretty good. Not perfect. Here's the problem with this kind of marking scale is essentially what it's saying is that if you get 80%, if you get 80% coverage, you've kind of only done half the work. Now, how you would normally do this, maybe mathematically, is you would normalize the marks. You would say, okay, well, if someone gets 60%, we're going to reassign that to be 0%. And then, you know what I mean? So you kind of like take that 100 to the 60 thing and you stretch it out. So if someone gets 80, you scale them to 50. My problem with this is that it's confusing. I think normalizing marks is really confusing. I think it's like, because you have to sit down and it's hard to express in a formula. So what we've done instead, which we think is, I mean, this is an example of we like the philosophy but not sure on the execution. What we've done instead is we've said, hey, we're just going to multiply your coverage mark to the power of 3. And the reason we're going to do that is because this actually has a similar effect for you, where let's say you get 100% coverage, right? 100% to the power of 3. Let's just do 1 to the power of 3, right? You get 100%. What happens if you get 98% coverage? The mark you get is 94%. And that actually is what we think, because we're like, the difference between 98% coverage and 99% coverage, in our opinion, is an extra 5% of work. You know, it is an extra 5% of work. What happens if you get 90% in coverage? Your mark for coverage would be 73. Okay, that makes sense, because we think like if you get to 90% coverage, you are not 7/10 of the way there. Right? We don't think you're most of the way there. We think you're maybe half of the way there. So we're actually being a bit more generous than we probably should be here. And if you get 80% coverage, which most groups do without trying, you're getting 50%, which is kind of what we think it is. It's like a pass, you know? So that's why we have the power there, because it's basically just saying, because the coverage results are always skewed to the top, and 80% coverage is kind of like square on average, roughly, let's just do this and it all levels itself out. And this way you don't need to worry about normalizing or whatever. It's just, you know, it's just simple. You can plug this into a calculator. You know, you can plug your marks into a calculator. The leaderboard will be updated to do all of this. I hope that made sense. That was a little bit more in depth than I would have liked, but I mean, I guess at least you have some background. Great. Let me move on, because I'm cautious of time. We don't want to talk for much longer. We were meant to have 40 minutes for this lecture, but we'll try and wrap it up in 35, which is another 10 minutes. So in terms of iteration 2, the main thing you'll note, the main place you'll be spending a lot of time is on the interface board, right? It's been modified from iteration 1. The main difference is that instead of having functions, you have HTTP routes. Each route has its own HTTP method, which Jake would have talked about. And you still have parameters and return types and exceptions and all of this. And all of the routes that we had in iteration 1 have been relabeled with v2. Why have they been relabeled with v2? Because they have slightly changed. In particular, pretty much the only change in most of these routes is that they're returning or taking in a token now instead of an auth user ID. We can keep talking about that more and more. It'll make more sense next week as well. So we've got login, we've got register. We have some new routes like logout. We have a bunch of our old routes: channels create, list, details, join, invite, messages. Now we have a bunch more new routes. We have the ability to leave a channel. We have the ability to add an owner to the channel, like a admin kind of thing. We have the ability to remove an owner from a channel, to send a message to a channel, to edit a message, to remove a message, etc. And now we also have this notion of DM. So if you understand, like, you know, from Discord or Slack or anything, or Teams, you can create a channel, but you can also send a direct message to a group of people, right? Like I can do that on Teams as well. So you can create a direct message chat. You can get a list of all the direct message chats, remove one, get the details of one, leave one, get the messages from one, send a message to one. You can also get all the users in the system. You can get a profile of a user. You can set the name of a profile. You can set your name of your profile. You can set your email of your profile. You can set your handle of your profile. You can remove a user as an admin if you have those permissions. You can change other permissions. You can also clear it. So there's a lot more routes here. And iteration 2 is definitely bigger. Iteration 1 was meant to be quite contained in terms of the workload, because we know you're trying to get your head around Git and PyTest and Python, and it's like a lot of stuff. So this one we've said, all right, let's do some real work now, you know, some real chunky work. Besides that, everything else in section 6 is the same, though we have added some more sections around token, working with a front end, raising errors on the front end, user sessions. You can go and read all of this. Like we've actually kind of elaborated on a lot of it for you. You can always ask in the forum. We can always do some extra lectures, do some extra help. That's totally fine. The only thing I'd probably say here is that we actually have an example implementation of our system here. So as in, remember how we said this whole spec is that you're building a backend for someone else who's building a front end and we're building a system together. You can actually see what a completed iteration 2 server looks like when it's running against a front end. So I could register here. You can go register too. Like you can just go and register for this. I register and here is the application. I can go into a channel, sort of, join the channel. There's a few things that might look like bugs, and they probably are, but I can send a message like, hey, you know, and that'll get sent, etc. Now, there are a few things in this that are also going to be part of iteration 3, so if you see things that aren't described in the spec, you don't have to freak out. We just build one front end for the entire course. But, you know, you can invite members, and this is here to give you a tactile sense of what this is all about. You know, like we're building a server, okay, and there's this front end, and it's like, this is how it would all come together. So this is a front end built by some abstract people that is powered by a server, and we could, by the end of iteration 2, literally replace our server with your server because you've implemented everything, and that's kind of the point. For iteration 2, there is an expectation that you can clone a copy of the front end, which is in a separate repo that you can all access, and you can run your backend against it. This is something that you don't need to worry about until, like, I'd say don't even worry about this until like week 6 or something like that, or days before. And I always get these people there's always people who are stressed who say things like, what do you mean I have to have it work with the front end too? Oh my God, that's like, so, you know, that's like more work. But the thing is, the front end just implements the specification. So it's like, if all your PyTests pass and you have good coverage, the front end should just work. And if it doesn't work with the front end, you've probably got some bugs in your code that'll come out in the auto marker. Like if you get 100% in the auto marker, the front end will work. And if you don't get 100%, it won't work. And you could even use that if you'd like to. We have weeks to talk about this. You could even use that to help you debug things. You could even use that to say, wow, the leaderboard gave me 80%. I wonder what we're missing. I know. Let's go and play around with the front end, connect it to our server. There's all the instructions. It's all written here. Let's play around with our server and done. We can start debugging. Now, someone asked a question earlier in the chat today, which was Eric. Hi, Eric. I don't know if you're still here. I'm sorry if you're not. What happens if we didn't fully pass iteration 1? If you didn't fully pass iteration 1, you just keep working. It is a 50% project. They're not 3 different assessments. These are essentially milestones along the way. If your group for some reason did absolutely terribly, like you, usually one group a term, just one, is such a group that is struggling that we let them skip an iteration and average some marks. But this is if a group's doing badly. So if your group didn't even do a quarter of iteration 1, then come talk to your tutor and they'll talk to me and stuff, you know. But most of the time, for most people, you did most of iteration 1. You just got to keep going is the short answer there. Okay, great. I think I've covered all the key things I want to cover. Probably the only thing that I want to mention that has changed is that, and I'm sorry for this in advance, we're only going to run your leaderboard 3 times this iteration. Sorry. The reason for this is that really, truly, just because the marks were extremely high. And again, it's a good thing. The solution to the problem of the marks being high is not to remove the leaderboard, it's to make the tests harder, right? That is the pride approach here. We should be writing harder tests. So when this course runs again, if it runs the same way, we'll still give all the leaderboard and the 5 things and stuff, but we'll have to write harder tests for students because like we need a way to separate students at the top end, right? In some way. In the meantime, because we can't rewrite tests, we're just making a slight adjustment that says we'll run your thing just 3 times instead of 5. We'll just make it a little bit more challenging, right? Nothing crazy. Now, in terms of all this, because we're only running it 3 times, we're also going to run it 72 hours apart. Sorry, 48 hours apart. So you have more time. So we're not just going to like run it bam, bam, bam 3 days before it's due. We're actually going to run it 6 days before it's due, 4 days before it's due, and 2 days before it's due, right? So we are stretching it out because we know that's the main thing that matters, right? Like you want this sanity check. 6 days out, you can be like, this is where we're at. Let's figure out what's wrong. Okay, I've talked about all of this. Let's actually quickly clone this repo, run the server, very quickly talk about this. I'm aware you all have places to be. Well, some of you do. Probably everyone here might not, I don't know. But you know, I have things to do as well. Okay, so we've got our code here. Now, the main thing you'll notice immediately is that I don't know what where that sentence was going. Sometimes I just say words and I figure out what I'm about to say, and people think I know what I'm talking about. Okay, so iteration 2. What's the main difference? You still have a test folder, you still have a source folder. The main difference is that we've given you a server file. This is your Flask server. Now, because you've watched Jake's lecture on Flask, you should get the basics of Flask. Now, the thing is, when you look at this file, you probably think, that's not what I saw in Jake's lecture. And the answer is correct. Well, the point is yes, because we've had to add some extra stuff here to make things work. However, what you will notice is if I scroll down, there's actually one section here that looks really familiar to what Jake was doing in his lecture, or at least the start of it. And that is this part here, which is the which is the route part. So most of the rest of this server is actually about running it. It's about configuring it to deal with exceptions. It's about handling the exceptions and a few other things. But the main thing you need to be concerned with is just this part here inside of these comments, because this is where you actually go and start writing routes. So you as a student, when you are doing iteration 2, essentially what you're going to be doing is you are going to be coming along and you are going to be like taking these routes and saying, oh, I'm going to make a new route. So I've got another route, app.route, this /auth/login/v2, and you know the methods is post, you know, like this, and then def login. Like this is what you're going to be doing, and you'll be doing the same stuff you've seen in the lecture. And that's like what iteration 2 is in a nutshell. And then you write tests for this stuff as well. So I want to focus on the echo example because it's like a really simple example. So if I just go Python 3-m source/server, which is how you can run your server, it'll start up a server on this port, you know. And if I open this in a web browser and I go to this URL, nothing loads because the Flask server doesn't have anything on that port, right? The Flask server is just a server that's running and it's listening for people to talk to it. And when people try and talk to it, it says, what do you want? And someone says, I want the default URL. And it says, I don't have that. Sorry, go away. But what it does have is the echo URL. So if I go /echo, again, when I call this, I say, hey, Flask server, and Flask server says yes. And I say, do you have /echo? And it says, I do. And then it tries to load stuff, and the server, oh, I'm on the wrong port. Am I on the wrong port? I'm doing this on my local machine. Actually, I've never done this before, and students do it all the time, so I'm glad I could demonstrate this. Don't make this mistake. I am running Flask on CSE. This browser is my local computer. They are separate computers that have no idea what the other one is doing. They can't talk to each other. So to actually run this, you need to open up a web browser in VLab like this. And actually, you know, load up the URL 8080/echo. Okay, data null. Great. Okay, so that's my web server actually working there. Now, what I want to do next is I want to actually make it work, and it says, okay, well, if data is echo, it raises an error. Otherwise, it returns me what I put in the URL. Now, remember, with GET requests, we put our data in the URL itself. So I could say here that, you know, echo equals hello. Oh, is that not what it should be? Data, sorry. data equals hello. And you can see that what's actually happening here is that my web browser is sending a request to my Flask server. My Flask server is running, listening on that URL. It says, hey Flask server, do you have a resource that exists called /echo? And my Flask server goes, yes, I do. Are you a GET request? And the web browser goes, yes, I'm a GET request, because everything a web browser sends is a GET request. And then this thing says, great, okay, I know how to deal with it. I'm going to run this function, and now I'm going to get the data from the URL, because Flask has this ability to get data from a URL for GET requests. So we pull out the data variable here, which we know is equal to hello. We've stored it in this particular variable. We check if that value, which is hello, is echo. We raise an error if that's the case. Otherwise, we return a JSON dump of some response back. You know, so in this case here, this is just a dump of a dictionary that just has data in it. So I could say return value here. I could do that, return value. And when I restart my server and I do this, it's just changed what it returns, right? So it's like browser contacts Flask. Flask runs this function. Flask returns this. Returns what you ask it to. Dumps is the JSON dumps method. So that just converts the dictionary to JSON, because everything Flask returns in this project is JSON. It all returns JSON. It's like, here's a JSON dump. Everything is JSON. Now, in the project, you're not going to be using a web browser to talk to Flask. You're typically going to be using an API. Did Jake run you through API clients? I didn't get to watch his lectures yet. Did he go through like Postman or ARC or Insomnia or just one of those things to like test that out? Just checking if anyone knows. Sorry, he's waiting for a response. He used Postman. Okay, Postman's great. He didn't really go through how to use it. Okay, well, I mean, that's kind of how you're probably going to do most of your debugging. Okay, well, let's have a look at that. I'm not sure. We'll figure that out. It's not a big deal. So, maybe. Well, okay. So, in terms of this, how you're going to actually interact with this is not through a web browser. It's going to come through one of two forms. It's either going to come from the test that you write, or it's going to come from using a tool like Postman. And when you write your tests, you can write them in your test folder just like last time. And you know what? Let's actually make one. I'm going to call this one echo2test.py, because it's a different test to the last one. And in fact, in the spec, we actually give you a stub for echo test. I think I put this somewhere in the spec. There's a whole file here I let you copy and paste to get you started. Now, this came from the 4.3 lecture you would have just done with Jake as well. And you can see things here as like slightly different. You can change around this a bit. But basically, it's like you can just use PyTest for this kind of thing. Word wrap. You can just use PyTest for this kind of thing where you say, you know what? When I call PyTest, it's going to run this test echo function, because the file ends in _test, the function starts with test _, and I'm going to call request.get. I will call this URL /echo. Where is this config.url defined? It's actually defined in a file that we push to your repo here, like this. You can change this if you want, where port's 8080, and this is the URL. So whether 127.0.0.1 and localhost are the same thing on a computer, it can be either. /echo. So this will actually make a GET request to this URL, and it will pass in the parameters data hello. So I actually give Python a dictionary, right? So it's actually, it all spells itself out very clearly, even if you aren't familiar with the syntax. And then you know what? I can take the response. I can convert the response to, I can load it from a JSON, because the response body is going to have the JSON in it, and I could convert it to JSON. I think in the lecture Jake used the .json method, which we can talk about in a sec. And we check if it's the right data. This is us basically checking if it works. So now what happens is, if I want to run this, what I can do is I can open up a second terminal. So slow. I've got my server running, and now when I do pytest test/echo2 test. I want to run my echo2 test file. Does that file exist? Did I name it something else? Or is it test? Oh, tests. Sorry. You would all know that. Test/echo2, it will actually call the server. And you can actually see this on the left here. See how it's talking to the server? Like it's actually like, oh, I got a request. So the server's actually telling you, hey, someone called me and they actually asked for the get request for /echo. They gave me this data in the URL and they returned a 200. But the PyTest failed because in our implementation, we didn't match what the test wanted. So the test expected this object to be returned, but because I modified it to return value, it wasn't passing. So if I rerun this now, it'll say running on that, and then when I run this, it will pass. And you'll see every time I run PyTest, it's talking to the server, right? This is a big reason too why all of your routes need to clear things at the beginning of each test, because your server just runs forever. It's basically in a giant while true loop, right? It's just kind of like quite literally running forever. So, you know, it'll just keep running and running. So it'll actually bulk up all this information for you. In iteration 1, the reason you needed to clear your tests every time was because you would run 10 tests in a single life cycle of the code. But this time, it's not only that, but when you run PyTests again, while the server's still running, it's actually got the same data. So like each set of PyTests you run, every time you run the PyTest command, it's actually going to still be using the same server. So that's why you also need to put the clear function in. Now, people have asked, oh, how do we deal with exceptions in this iteration? Well, one thing we've done is we've updated the error.py file. The error.py file used to have some other stuff in it. You don't have to touch this. And this time what we've done is we've said that an input error is a 400 status code error. And I think Jake talked to you about status code errors. But basically every time an HTTP request returns, it returns with a number that tells you what happened. 2xx errors mean things worked. 4xx means that the person calling it made a mistake, so the person talking to the server screwed up. 5xx errors means the server screwed up. So there are two types of errors we had in iteration 1. Access error, which says you can't touch this, and value and input error, which says you gave us the wrong thing. And if we go to HTTP down here, you see that for 4xx errors, 400 means the server will not process this because of a client error. Invalid stuff, it's basically wrong stuff. And 403 is forbidden. You're not allowed to access that. So what we've given you, and you don't have to touch this file, you don't even have to change your imports really, is the access error and the input error are now kind of ready to be dealt with servers, right? So they're ready for servers. And you'll see here, even in my server, what I'm doing here is that when there's an error, because remember the echo route fails if someone gives it the data echo, it actually raises an input error. It's exactly the same as iteration 1. The only difference here is that I'm also giving it a description. Now, I don't think you have to do this. I think you might have to put it in even if it's just blank. I don't think we use a description for anything at all, but I think it's good practice because it actually it's kind of clear what's going on. So in this case, I've just got this description. So all you would need to do in terms of your own code is just modify this to include the description. And then how do you actually test with these errors? Well, and again, I think Jake went through this because I did pop into the lecture where I could, is you'd actually just, when you're getting this, you could say, I could do a test where, PyTest raises works, PyTest raises works the same. Wait. I don't think so. That's why we've changed it. So let me just show you here quickly. It's like, okay, so just to take a step back. Someone said, does PyTest raises work the same? The answer is not really, but also it doesn't really matter because you're going to have to kind of write a layer of stuff over this anyway. But here's how you would check for an error. You'd say if response.statuscode equals, well, actually, I'll show you this here. Okay, so we make a request. The data's hello. We check if the data matches. Perfect. I'm now going to make another request, response 2. is request.get config.url plus echo. Params is data is echo. So I'm going to do the naughty thing that's going to raise an exception. Now what I do is I'm just going to assert that my response to dot status code is equal to 400 because that's what I should get here because it's a value error. And now when I run my PyTest, I don't have to restart my server because I haven't changed my server. This will now fail because I can't type. Requests. Great. Run. Both pass. 500 error. What does this mean? Why do I have a 500 error? A 500 error means the server has done something wrong. So stop looking at your test. Go to your server. This I didn't expect to happen. Why is the server complaining? Input error. 400 bad request. That shouldn't happen. Maybe there's been an update to Flask or something. This is the same stub code we gave last time. Why? Why? You can actually see that it's raising 400 bad request. I don't know. That's quite strange. That should come out as a 400 error, unless I've just made an obvious mistake here. But let me go and look at that with Emily after. But basically, this is how you would test this kind of stuff. So in iteration 1, it was like you assert all these properties are true, or you do with PyTest raises. But in this iteration, instead of that, you will basically just be checking the status codes, because instead of PyTest raises input error, you're going to just be doing like check that the status code is 400. Because here's the tricky thing to understand about this. Just because your tests are written in Python and just because your server's written in Python, it doesn't mean they understand each other. Like, this isn't two pieces of Python running together like in iteration 1. This is actually two separate systems. You could write your tests in C. You could write your server in C. You could write your tests in Java. Like, it doesn't matter because they're communicating via HTTP. And in fact, 4.1, the lecture was about standard interfaces. HTTP is a standard interface. It's a way to say, this is a standard way. You get a URL, you get a path, you get some data, you send it across, you get some status codes. Don't care how you got it. Don't care who's receiving it. That's the standard. So that's why PyTest raises doesn't work, because you can't return an exception to your test because HTTP doesn't have exceptions in it. It's not Python, right? So anyway, this is where you should get a status code of 400. Now, you mentioned that Jake showed Postman earlier, but didn't really go into it in detail. I probably do have to chat about this quickly for completeness then. He might have done it fine. I don't know. It's just better to do it now while I'm recording. Is that if I open up Chromium, and this is how I do it. Now, two really common tools to use to help debug your server are Postman. Well, Postman's a very common one. I use a different one locally for my own work. Though the one I generally push students towards, and again, you can use any. Postman's fine. Lots of students use Postman. I don't use Postman myself. Though I really like ARC because it's really simple. Like, it's kind of stupidly simple. I would not use this for professional reasons, but I think it's a very simple tool, and it's exactly the same as Postman, just a different UI. The cool thing is that you can add this to Chrome just like Postman. I think you could just add it as an extension. I just did this on VLab, and you can just open it up. Like, the setup is laughably straightforward, and basically, all this is a tool whereby, like, if you have a server, you know, like I have my server here running, and over here I have like it running whatever, I can actually, with a GUI, kind of test stuff. So I can say, okay, I'm going to test HTTP 1.0.0.1, port 8080 / echo. Now, do I need to give it any headers? No. What do I need to give it? My data, right? Data equals hello. And I can click send, and then it should send it. Did it not send it? Yeah, okay, send, like that. Right? Cool. Great. So you can actually see here, it shows you a lot of stuff. It shows you that the server responded with this kind of information. Surprised it's giving you text HTML, but that's okay. Oh, that's just how the route was designed. I don't know. You know, so I have this, like, this is the response, and I can change this around. And if I'm doing a post request, because like, let's really quickly, just for completeness, do a post request, like auth login v2. Let's just capture that data, because remember with post requests, we do request.getJSON. And then what I might do with this request is let's assume that what I want here is like a username. So I could say username equals data username. And then let's simply return a dictionary that includes that username except adds 123 to the end. This is just a benign example to kind of convey a point. So it's like someone tries to log in with a username Hayden, and I'm going to return them Hayden123. So there's the change to my server. I run that, right? And now what I do is if I want to create a new method, because I could, oops, I should be able to save this one. I can click save, sure, /echo. And now I have like a list of saved routes and stuff here. At least I should. Oh, I can just use history. I don't know. That's okay. I haven't used this in a while. So I've got my login route, but here's the thing. With GET requests, you do put the data in the URL, but with other requests, like put, post, and delete, you put the data in the body. And you'll actually notice this. Notice here how when I go to GET, the body disappears, but with post and the other ones it appears. And in the body, I'm going to want JSON, and I can use the JSON visual editor if I want to. Sure, whatever. Like, I could just write it in raw. Let's just write it in raw. Because what I'm going to give it is the username is Hayden. So that's like the payload that I'm going to send. And now when I send that and I click send, I get a 500 internal server error. I've made a mistake on my server. So I go look at my server terminal. It doesn't give me a lot of information sometimes. It says there's been an exception on /login. It says 404 not found. What is that from? Did I actually restart my server? That's kind of the first question you should ask yourself. No, I did, but I gave it the wrong route. Right, so it couldn't find it. Read the descriptions. It's actually telling you it couldn't find it. And that makes sense because I gave it the wrong route. So now I try this again. I click send. 200, okay, it worked. That's the response I got. I gave it username Hayden. I got back Hayden123. So if you actually just think about HTTP routes as functions, it all makes a lot of sense. The only thing is you have to tweak a little bit on the input, tweak a little bit on the output, because you've kind of got to convert things to JSON and get them to JSON. And what I'd recommend for all of you, and I'm hoping I'm coming to an end here, I actually have a meeting in 5 minutes, is that what we want to do here, what I'd recommend you all do is that many of you from the previous iteration will have something like a login function here. And this login function will return, say, a token. And this token might have been, in the previous one, it might be like auth user ID. But let's pretend for a second that you do something here. You're like, if email's blank, then we need to, raise input error. Description equals no blank email or something. And then you do a few more things. You do the same thing for password, right? Like, this is what your iteration 1 was. And your files are still there. And then what you might do for this iteration is you return, say, a token, which is like an auth user ID. And maybe that token will be like, the user ID is a string. I'll come back to that in a sec. And there's your auth login function. Forget Flask, forget any of that. Now what you can do, and this is genuinely how I'd recommend you all do it, is you can just treat your server.py as a wrapper, as something to wrap it. It's something to handle the web and abstract it away. So now when I have my auth login v2 function, what I'm actually going to do here is I'm going to go from source.auth input auth login v1, sorry, like this, the function I wrote. And I'm simply going to come down here and I'm going to extract the data from the HTTP request. I am just going to get, the token. What's the response? The return is calling that function, and I give it the data and the username. The username and the password, sorry. And then all I simply do here is just return the dumps of, say, token, return token. So all this little route is doing is it's just wrapping it, right? Like, you're actually reusing the exact same logic you had from the previous iteration. And this is really handy because your server.py file is now essentially handling the HTTP aspect, and your function is handling the logic of what's happening. And this is a really straightforward pattern that will allow you to build really rapidly on top of the stuff you've done in iteration 1, and it will help you separate out your code as well. So now when I run this, if I've done this correctly, which like I haven't, what's wrong? What file? auth.py. Oh, damn tabs and spaces. When I run this and I open up ARC and I call this again, but let's give it a password of say blank, and I run it, I get a 500 error, no blank password. This should be a 400 again. Let me talk with Emily. Like, we'll go and fix this for you. This should give back 400, not 500. You know, but if I give it a good password, like, and I click send, you see we get a 200 error and I got back token 1. So this isn't some big new thing where you have to rewrite all your code. We're actually just saying that you've started to write the mechanics of how a system works. Let's now elevate that so it can actually run as a standalone web server. That's the gist of it. Now, I've mentioned token before. What I would recommend for all of you with iteration 2 is that what you do is you just simply start this iteration passing token as a string, exactly the same as you did in iteration 1. Send the user ID but as a string. Then when you're feeling like you have the time, go and read the token section, the session section, which explains what a token is. And then try and do that. And then next week when we talk about auth stuff, we can get into that more. But the reason I point this out is because, and we'll have to wrap up, I'm sorry, is because I've actually got a pin post on the forum here which we can all talk to and stuff. So if you have questions about token or whatever, we can talk about it on the forum. I've tried to be helpful there. So yeah, I think that's about it. That's really all iteration 2 is. I know we talked for a while. I'm sorry about that. Thanks for those who hung around to ask questions. We'll wrap up now. If you do have any other questions, please post on the forum. I think everything high level that needs to be covered, we've covered. All the other details are written in the spec. And if you need any help, ask me, ask your tutor. We're here to help because we think you guys are awesome and you're doing a great job. So like, good job in iteration 1 and get started on this weekend. Halogen says, quick question about ports. Is the error associated with another group using your port number based on the port being used in that moment? Oh, okay. Basically, God, that's a great question. I think I normally cover this when I do Jake's lecture stuff. Basically, CSE has 16 VLab servers, and then they have a few servers for VS Code, and you're all sharing like 30 servers. You might be on them randomly. Like, you can see what server I'm on here because it says in the terminal VX7. So I'm on the 7th VLab server. That's one computer essentially. So like only one port on that computer can be used at a time. So sometimes on VLab, if you get like a port not used error, you can just go and change it in the source config file because it means someone else who's on that specific VLab server VX7 is using it already. That's all that means. If you're on your local machine, you'll never have this problem. If you're on VLab and stuff, you might. So just keep an eye on that. That's a good question. Sarah says, does that mean we can't use Flask with VS Code? I don't know off the top of my head how to sort that problem out, but generally what I would say is that use VS Code with SSH and stuff, but load up your web browser in VLab too. So like do all your coding stuff locally, terminal VS Code, but maybe just have a VLab up with the web browser. That's probably the easiest thing. Tokens we'll talk about. JWTs we'll talk about next week. Sorry that I do have to run. I'm sure many of you are like, you know, whatever. Jaishan, if you're running everything in WSL, would it work on a local browser? Yeah, it would. But I hope this was helpful. If it was helpful, please leave feedback. I don't think I have any slides for today, but that's okay. You can't leave feedback, I guess. But thank you, everyone. If you have any questions, please post on the forum. Here to help. Hope you've had a good time. Reach out anytime. Have a good day.